Hi pre-calc students, hi. Okay, last video for this goofy COVID semester. Okay, we're going to do something called amortizations. I don't know if you had French or not, but this is what that word means. Mort, the way we would say it in English, mort, means death. Think about it, mortuary. Right? Rigor mortis, death. Amortization. That's how I remember the difference between annuities and amortization. Amortization has to deal with debt. And debt sounds a lot like death. And when you get a 30-year mortgage on your house, I'm pretty sure everybody says, I just signed my life away. Because that's how it feels. So, little fun fact there. Okay, so this has to deal with debt. And here's how the formula looks. And this is on that, the formula thing that I put on CourseWeb. Okay, so let me explain this to you. Notice that the letters are all the same that we use in annuities, they're just all moved. Okay, this is your monthly payment. Now an amortization is whenever you make the exact same payment each month on a long-term debt, like a house or a car payment, okay? So this is, we're going to do months just like with the others because that's the most practical. This would be your monthly payment. This would be the total amount borrowed. That's your APR, how much interest rate you're being charged per year, divided by 12, because we're doing months. Okay, this is a 1, that's a minus, that's a parenthesis, that's a 1, that's a plus. I is the same as this, APR divided by 12, and minus N. N is the total monthly payments that you're going to make. So if you have a 30-year mortgage, that's 30 years times 12 months, that's 360 payments. If you have a car loan for 5 years, 5 times 12, that's 60 payments. So you would have minus 60 there. These are really pretty simple. Okay, so example number 1. We're going to borrow $25,000 at an APR of 7.1% for 5 years. What's the payment? What's the monthly payment? Should have stolen more markers from the office at school. That would have been good. Okay. So in this case, I'm solving for the monthly payment, which is our R. So R is going to be equal. That's not going to work. Try a different one. Please work. Okay, R is going to be equal to my total amount borrowed, $25,000. And then my I is 0.071 divided by 12. Then 1 minus 1 plus 0.071 over 12 to the negative 60. Okay? And I get that 60, that's 5 times 12. 5 years, 12 months in a year. Okay, so that's the total number of payments. Super easy to figure out what goes where. Putting it in your calculator can be a little tricky. And everybody's calculator is a little different. I love my tried and true old Casio rattles. Okay, the easiest way, what I would recommend is to figure out what this value is, 0.071 over 12. So 0.071 divided by 12 equals. Again, you're going to get a scientific notation, which sucks. So add 1 to it. Then it takes it out of scientific notation. And by adding 1 to it, I get this whole value here. It's 1.0059.
Okay,
This value is the same as this one, okay? But to get it out of scientific notation, I added 1. So just this part after the 1 is what this is. So 0.0059. Like Arabic, I'm going that direction. Okay, so now keep in mind this, what we get in here is being taken to this exponent, not this other guy out here. So I take what I have here to the negative 60 power. Okay. If you keep rounding, you're going to get a pretty different answer than I have, and that's fine. But I need this to be negative, so you can switch it to negative on your calculator, or you can multiply it by -1 and then add 1 to it. Okay? And here, I'll write this one out. I usually do this all in one step in my calculator for myself, but it's kind of hard for students to understand what I'm doing, especially given our method here. Okay, so 0.0059 divided by 0.298 equals times 25,000. I'm just rounding to the nearest dollar. Okay, now you should always be able to see if it's in the realm of possibility that your answer would make sense.